So you're welcome to Diary of Teacher Olumide. And today we have this question on the board that says if alpha and beta are the roots of this particular equation, then we have been asked to find the value of first one, alpha squared plus beta squared, and 1 over alpha plus 1 over beta. Now I'm going to be establishing some things before we delve into this question totally. So first of all, there is a generic way to represent quadratic equation, and we have that generally quadratic equation is represented as ax squared plus bx plus c is equals to 0. Now the a you see here always represent the coefficient of x squared. The b you see here represent the coefficient of x, and the c is the constant. So now comparing it to the equation we have 3x squared minus 7x plus 5 equals to 0. So if we are going to get our a here, we said a is the coefficient of x squared. So that means a in this question is 3, b is minus 7, b is what is beside x, that's the coefficient, and what is beside x is minus 7. And your c, which is the constant, is 5. Now, the moment we have established this, there is also something else we need to establish, that as well, we have that the general equation for a quadratic equation is given as x squared minus sum of roots bracket x plus the product of roots equals to 0. So this is the general formula that we use in solving a quadratic equation. Now, this sum of roots, if you go back to the question, we're told that if alpha and beta are the roots, so we've been told that these two parameters are the roots. So that means if we come to this equation, it means the sum of roots, which represent alpha and beta. Sum in mathematics is indicative of addition. So we had it. Then the product of roots means alpha times beta equals to 0. So this is the general representation if we are given alpha and beta. Now, to go fully into the question we have, so let's clean this so that we are able to delve fully into the question that we have on the board. So we've been asked to find alpha squared plus beta squared. Now, generally, alpha squared plus beta squared is given as alpha plus beta all squared minus 2 alpha beta. So let me just quickly run you through how this is derived from this. Now, since the question asks us to find the value of this, so one of the things we can first of all do is, since there is a square that is common to the two of them, so I want to say alpha plus beta all squared. So what I want to try to do is I want to expand these two parameters that we are given, because I know if I expand this, alpha is going to later carry square and beta will also carry square. So alpha plus beta all squared, this is the same as this in two places. So if we multiply it together, alpha times alpha is alpha squared, alpha times beta is alpha beta, beta times alpha is alpha beta, beta times beta is beta squared. So that means this is equals to alpha squared. Now, alpha beta plus alpha beta is going to give us 2 alpha betas. One of this plus one of this will give us 2 of them. So we have plus beta squared. Now, if you look at what we have on this board, you remember the question asks us to find alpha squared plus beta squared. So if you look at this right-hand side of this equation, I'm already seeing what they asked me to find, which is alpha squared plus beta squared. But there is this in the right-hand side. So what I can easily try to do is to take it to the left-hand side. So that means alpha plus beta all squared. If this should come to the left-hand side, it becomes minus 2 alpha beta. So we are left with alpha squared plus beta square. So you can see that's where we got this from, that alpha square plus beta square is equals to alpha plus beta all squared minus 2 alpha beta. So anytime you are given a question on this, what you will use is alpha plus beta all squared minus 2 alpha beta. So we can go right into the question and just say, since alpha squared plus beta squared is equals to alpha plus beta all squared minus 2 alpha beta. Now, if you look at what we have on the right-hand side, this represents the sum and this represents the product. So we also need to establish that alpha plus beta is given as minus b over a. Yes, so this is the general representation. When you are given alpha plus beta, it is equals to minus b over a, where b is the coefficient of x and a is the coefficient of x squared. So if we just substitute right from what we have that this is minus, our b is minus 7 over our a is 3. So this is 7 over 3. Then our alpha beta as well is c over a. And c in this equation is 5. Our a is 3. So we have fully established our alpha plus beta and our alpha beta. So back to this. So we can then say that alpha squared plus beta squared is equals to, now alpha plus beta all squared is this, minus b over a, which is 7 over 3. So substitute it here. We have 7 over 3 all squared minus 2 times alpha beta, which is c over a, and that is 5 over 3. So 7 squared is going to give us 49. 3 squared is going to give us 9 minus, if 2 should multiply 5 over 3, remembering that 2 is the same as 2 over 1, this is 10 over 3. If we find the LCM, which will be 9, 9 in 9 is 1 times 49 is 49, minus 3 in 9 is 3 times this is 30. So we have that 49 minus 30, that's going to give us 19 over 9. So that means that alpha square plus beta square is equals to this. All right, so you can look at this solution while I clean this place so that we can attempt the second question as well. So for the second part of the question, we are still going to follow the same route, just that now they want us to find the value of 1 over alpha plus 1 over beta. Now, one of the things I didn't say earlier is that in finding any of this question, you must of necessity always get alpha plus beta or alpha beta, or you get the two at the same time. So, and the reason why you need to get them is they are the only ones you can substitute into any question, because alpha plus beta is minus b over a and alpha beta is c over a. So for this question now, the thing I can do is to first of all find the LCM. Now the LCM of alpha and beta is alpha beta. So alpha in alpha beta is beta. Beta times 1 is beta, plus beta in alpha beta is alpha. Alpha times 1 is alpha. Now if you look at this beta plus alpha can also be changed to alpha plus beta. And the reason is because addition is commutative. Addition is commutative. So 2 plus 3 in mathematics is the same thing as 3 plus 2. You can flip it around and you will still get the same answer. Now that we have established this, our alpha plus beta in this question is 7 over 3. So we can say alpha plus beta is 7 over 3. The division sign is there. Our alpha beta, which is at the denominator, is 5 over 3. So from here we can say 7 over 3 times 3 over 5. 3 cancels 3. And our final answer is 7 over 5. So this is how we approach any question on symmetric equation that is under quadratic equation. Thank you for joining me. Like and subscribe. Okay.